This conference will now be recorded.
Yeah, so if I ask you, what is sub-array in the array? How do you define sub-array? Feel free to use chat window to type in your responses. And if you are in a silent environment, you can speak up also. You can unmute yourself and speak up. What is a sub-array? Yeah, anyone? What do you feel is a sub-array? Feel free to type in your responses in the chat window. What is your understanding? What is sub-array? Yeah, guys, what is sub-array? Array we understand, but what is sub-array? Okay, if array is A, B, array in array, okay, I'm hearing responses. Mithil says, if array is 1, 2, 3, 4, 5, then 2, 3, 4 is a sub-array, and 1, 3, 4 is not sub-array, yes. So sub-array is a contiguous portion of array, right? It is like pick some elements of the array and take them continuously. So if you take 518, do you agree 518 is a sub-array? Yeah. Is 518 a sub-array? Can we say 518 is a sub-array of A? Yes. Because it is contiguous. Contiguous is like they should be together. You should take the entire chunk together. Then only we say it's a sub-array. If I ask you another question, is 513 a sub-array? What will you say? Is 513, we pick 5 from here, 1 from here, 3 from here. Is that a sub-array of array A? Yeah, what do you say? Oh, video is paused. Everyone is able to see me typing? I just typed yes. Now I'm typing no. So this should be visible. Okay. Yeah, so we were saying sub-array is nothing but a contiguous part of the array. So in this array, if you see contiguous part is 518, 518, it's a contiguous part. 513 is not a contiguous part. It is not a sub-array. Now if I ask you, if we have array of size n, how many sub-arrays of size k it will have? If we have array of size n, how many sub-arrays of size k it will have? If you want, we can take an example 1, 2, 3, 4, 5. And if now n is 5 and k is 2. Okay, many people are saying they're not able to see anything. Just a moment, let me see. Mithil says not able to see. Just a moment, I'll unshare my screen and share again. Yeah, Mithil, is it visible now? I just started sharing screen again. Can you confirm, Mithil, in the chat window if you are able to see the screen now? Okay, I think it's problem at your end. Okay. Sure. So my question was how many arrays, sub-arrays of size k we will have if array size is 5? Oh, there is a disturbance in my voice. Just a moment. Yeah, is my voice better now? Yeah, Vaishnavi, can you confirm if you are able to hear clearly now? Okay. Fine. So let's move ahead. If we have array of size A, how many sub-arrays of size k will be there? If you look at for 2 size, this is the first subarray, this is second subarray, 3, 4 is third subarray, this is fourth subarray. We have 4 subarrays. So many people are responding like formula for this will be, answer for this will be n minus k plus 1. Do we all agree that if we have array of size n, then total subarrays of size k will be these many, right? So another question, if I ask you, starting point or starting index of last subarray of size k in array of size k. And so first subarray we know it starts at index 0. This is index 0, this is 1. Second subarray starts at index 1 and set 2. This is second subarray. Can you tell me what will be the starting index of last subarray of size A, of size k? Where will the last subarray of size k start from? What will be the index? The formula for that. So see, if we have array as 1, 2, 3, 4, 5, and n is 5 and k is 2, our subarray 1 starts from which index? Subarray 1 starts from start index is 0. Subarray 2 start index is 1. This is first subarray. This is second subarray. Subarray 3 starts at index 2. Subarray 4 starts at index 3. This is index 3. This is our fourth subarray, right? So can I say, yeah, it starts at index n minus k. This is the start index for last subarray that we can have. So this is something, these are certain things, these are certain observations that help us when we are solving coding problems. So be aware of these small formulas, these small things when we are doing problems related to subarrays, right? So, okay, we learned about what subarrays are. Now let's take a look at a question. So problem 1 that we are talking about is, we are given an array of size n. We need to print sum of all subarrays of size k. So this is our question. Given an array of size n, we need to print sum of all subarrays of size k. So if example, sample input, if array is 1, 2, 3, 4, 5, and this time let me take k as 3. So what is the output? First subarray is, yeah, what is the first subarray's output? First subarray of size k. Can you tell me what is the output of first subarray of size k here? Yeah, it is 3. Is it 3? Manaswini, can you check? We are considering subarray of size 3. So that means 1, 2, 3. That is our first subarray. So its sum is actually 6. Second subarray, what is the sum of second subarray? Charita, can you keep yourself muted? There's disturbance coming from your side. Yeah. Second subarray, if you see, it is 2, 3, 4. The answer is 9. What is third subarray sum? Third subarray is starting at 3. So it is 12. So this is the problem statement that we are talking about that we need to solve, right? So problem statement is clear to everyone that we have array of size k, sorry, array of size n. We need to consider all subarrays of size k. If I ask you how many numbers will be the output, as you said earlier, the total number of subarrays are n minus k plus 1. So our n was 5. Here n is 5. K is 3. So it is 5 minus 3 plus 1. So we have 3 answers available here. And starting index of last subarray of size k is n minus k. And that is where it started at 3. So ideally, if I have to solve this problem in a brute force way, like I will say its brute force solution will be, first for I 0 to n minus k, less than equal to n minus k, right? Because we know last subarray will start at n minus k index. So I'm taking starting point. For starting point is equal to 0, starting point less than equal to k, and starting point plus plus. For every subarray, starting at start index, what I'm doing is find sum of k elements. How do we find sum of k elements? We start from the start point. Let's take for I is equal to start. Then I will say I less than equal to start, I less than start plus k, then I plus plus. So I can get the sum of those k elements like this. And this sum I can declare here, sum is equal to 0. And then we are doing for every starting point to up to k we are going and we are adding. So we are saying sum is equal to sum plus a of I. So this way we are getting sum, and for this array I can print this sum. This is the brute force algorithm where calculate sum of each sub array by looping over k elements. Now you need to help me understand what is the time complexity of this solution for this entire array. How much time will this code take? You have to give me a formula in terms of n and k. Can you tell about what is time complexity of about approach, about thinking that we have done? So how do we do time complexity analysis? We talk about how many times this loop is running. Outer loop is running how many times? It is going to run k times or n minus k times. What is your answer? How much time or how many times will this loop run? This highlighted line. It will be n k, right? It is starting from 0 going up to n minus k. And inner loop is running how many times? It will be running k times, right? So overall, can we say the time complexity is n into n minus k? For H5, it is not n square right now. We are saying actually this algorithm is based on two variables, n and k. So we always express in terms of n and k. In worst case, yeah, if you want to leave number k, then you will say n square. N square is certainly the upper bound of this. But here in this case, we will say n into n minus k. Now imagine if I say n can be up to 10 to the power 6 and k can be up to, let's say k value that I'm taking can be minimum value, let's say k is 3. If n is 10 to the power 6, k is 3, then how many operations will this algorithm require? If n is up to 10 to the power 6 and k can be anything up to, let's say, up to 100 also, or up to 1000. If these are the values of n and k, then our overall solution that we see, it will be taking very long time to complete because it is nearly equal to, you can say, 10 to the power 6 into 10 to the power 3 in worst case minus 10 to the power 6 minus 10 to the power 3, right? Which is in magnitude. If k value is less, then in magnitude it is going to be 10 to the power 12. And if we submit this solution for n is equal to 10 power 6 and a test case if I talk about and k is 4, we will get TLE. So this solution is not going to be acceptable. So we need a better solution, and that is where we come to this point of sliding window technique. So what sliding window technique tells us is, sliding window technique says that if you want sum of the next sub array, imagine this is our array we are considering. Let's say we are taking 1, 2, 3. This is our array and we are considering k is equal to 3. Window size, we call it window size. And then next element is 4. So first three elements sum, first window sum is actually 6. Now we want to know, once first window sum is printed, we want to know what is the sum of second window. Is there any way you can calculate that in big O of one time? If you know the sum of first three elements, you want sum of next three elements. Can you give me a formula with which we can calculate the next sum very quickly without writing any loop internally? The question is clear. We got this sum as 6. We want, yeah. So overall point that you are seeing is we are removing this first element and we are adding this as next element. That is what our window is becoming. And this is why it is called sliding window. So sliding window simply says, let's calculate this window sum. So first window sum that we get is, here the sum is 6. And if the next element was 4, in order to get the next element and this sum, it is simply 6 minus 1, which is coming from here, and plus 4, which is coming from here. That will give you the next window sum. Yep. So it is like, yeah, Abhishek, this is like replacing first element with fourth. So next window sum that we are getting is minus 1 is 5, 5 plus 4 is 9. So we got next window sum as 9. Now imagine if next value is 2, how do we get the next window sum? This will be subtract 2 from 9 and add another 2, which kind of remains same 9, right? So ultimately now the technique, the approach that we are working on is sliding window approach says, find sum of first k elements first, and then next window sum will be equal to sum of previous window of size k minus a of, can you tell me what the index will be? If you are calculating first window, see this, let's call this window as our 0th window because it starts from 0. This window as the first window, it starts from index 1. So we have sum of 0th window, which was starting at 0. That k elements we know. Can we say minus for first window, sum of window starting at index I is equal to sum of window starting at index I minus 1 minus a of I minus 1, right? Plus a of, what do I say? Plus a of sum of next sum window sum of size k will be equal to, so which index we will add here? Think about it. When we are talking about this window, we have subtracted a of 0, and which index are we adding? A of 3. Can we say that it is a of 3? Can I say it is I plus k? Right now, when we think of this approach thinking wise looks pretty simple, and coding wise also you will see it is pretty simple. Then what we are doing is, when we define a window, we define starting point of a window and ending point of a window. That will be much simpler. So starting point of window is this, ending point is this. So we have found the first window, we calculate the sum of it. Now what happens? We shift ending point, we shift starting point. That is how we continue. So ideally, if you see what this sliding window techniques code will look like is, we say, let's take our starting point as 0. That is our starting. Our ending point initially is also 0. Right now, window is not even expanded. And we should also have k with us. What is our window size? Right. So two things we have. We have array, we have its window size, and that is what we are looking at. That is what we are solving. So we have array and we have k here. Now this is the sum we need to actually print. So if we see how we will print, we took a start, we took an end. So let's do one thing. We take end is equal to 0. I don't need to declare it again. So end is 0, end less than k, and end plus plus. You will see what I'm going to do here is, this should be less than n. And how do I get n if I have a vector? You have a vector v. how do you get what is the length of the vector? How many elements are there in the vector? How do we get number of elements in the vector? V dot size, right? In place of vector, we could also have an array. So if array is there, we would be passing size of the array. So we are taking vector, size of the vector. Now we are saying, let's improve, let's run the end of the array. So it is 1, 2, 3, 4, 5. So what we are doing is, initially starting point is here, ending point we are expanding. So ending point is also here. As we move ending point, we will keep adding the current value in the sum, right? So I will take a sum variable. Let's take sum of window initially is 0. Now what we will do, we will every time we will say sum of window is equal to v of end. So initially, if you see, we have added 0th element. Then in this loop, we will add first element, then we will add second element. When will we get the first term? What is the value of end when we will get the first window sum? Can I say if end is greater than equal to k minus 1, only then we will be considering the sum. Otherwise, whatever sum is accumulating, it is not of our interest. Just see. 1, 2, 3, 4, 5. Let's work out our approach. This is our end. This is our start. This is our sum of window, which is initially 0. Now what I'm doing is I'm saying in the loop, let's add v of end. So v of end is nothing but 1. We are adding 1 to it. First iteration of the loop is happening that way. Then end plus plus will happen. End will come here. Then I'll go and say sum of the window now becomes 1 plus 2, which is 3. And now again I check k was supposed to be 3 size window sum we are calculating, but our end value is still, end was 0 here, end is 1 here, end is 1, end is not even less than greater than equal to k minus 1. The moment e comes here, end comes here, we got our first window completed. That's where we will come and we will start taking a look at that. So when we come here, the sum of window will be 6, 3 elements have been added. And now we say, okay, this is something that is of our interest. We got the first window sum, which is SOW. Let's go and print that directly. So 6 we will print inside the if condition, and we will also calculate sum of the next window. And for sum of the next window, what will happen? End will automatically get added, but we will start removing the starting point here. So you will see what I will do. I will say cout. Sum of window we got here already. Whatever is the sum of window, we have obtained that. Let's print that directly, because adding is already happening here. So this is where the expansion of window is happening, expanding here. Now, all we have to do is for next window, we will remove sum of window. When we have printed, we will say is equal to sum of window minus, for next window, which element will we remove? Can you tell me what should I fill here? What should be the index that we should remove from the next window? Your 1, 2, 3 first window is done. When we are moving next, 4 will automatically get added by this statement, but we need to remove 1. How do we remove 1? So Abhishek is saying we should do a of start. So start is removed, and let's also do start plus plus. So now you see how we are actually moving our window. Our start will be moving again and again, and start is moving only when we have subtracted a value. End is moving always. So this is how our window will be shifting, and this is what our approach, our technique for sliding window looks like. Right? Code is pretty simple. We are making sure every time we are changing end. End is guaranteed, it will change. Start we will change only when our window is complete. So shifting will happen that time. So 1, 2, 3, 4, 5. What technique we used? We took start here, we took end here. We started moving end dash, and dash dash. The moment end reached here, we said, oh, this is the first window. Whatever sum we have got, let's print that. After printing the sum, what we said is, we said, let's remove 1. It should be gone. That means let's move start here. That is what we did here, st plus plus. Now end will move here, and we have already made sure from some of the window we have subtracted 1. Now the moment 4 gets added by this line, we will eventually get the sum of the next window. And once we get this sum, again what we will do, we will remove this also, we will move start here. Now in the loop iteration, and will come to this point E4, and then this sum we will get, we will print that sum, and after that eventually this loop will get over because end will go out of bounds. So last sum that you get 4, 5, you will not even print that. So this is the approach for sliding window. Any questions from anyone? You can use chat window if you want to ask any question. Can you type in yes or no? If it is clear, please type yes in the chat window. If it is not clear, just say no, but at least be responsive. Can you type in if this thing is clear, the concept is clear? Okay. I see most yeses. Awesome. Perfect. So I believe like this concept is clear to people. Now this code we will try also. We will see that for our sample input, do we get the desired output? So what I'm doing is I'm creating an input file, and that input file will be first line. We will put number of test cases, which is 2. Let's make 2 test cases. Our first array is of size 5. Let me give window size as 3. So you see this line I'm putting as n and k. K is the window size and n is number of elements. So for this, we know, we worked out this example already. The sum should be 6, 9, 12. That is the answer that we are expecting on the output. I'm putting output below just here so that we know. This is our test.inp.out. Input output we are just working out here. So first test case, this is the output. If I come up with a second test case, let's say array size is 6 and my window size is 2 and array is 9, 7, 0, 1, 2, 5, 2 to 4 to 6. Okay. Now can you tell me what should be the output for second test case? For every window of size 2, we want to print the sum. So for second test case, what should be our expected output? It should be 16 as the first number because first 2 element sum is 16. The next 2 element sum is 7. So Ritesh, check your answer. We are considering windows of size 2, right? First window is this, sum is 16. Next window, Ritesh, it is 7. Sum of those two, yeah. So that should be 7. Third window is 0, 1. So answer should be 1. Then fourth window is 1, 2. The answer should be 3. Fifth window is 2, 5. The answer should be 7. So this is our output, expected output. Now, what we will do, we will put up this code in IDE1 so that you can have a reference to this code. I'll share this link also with everyone. So this is our kind of getting started problem where we are visualizing what sliding window looks like and what our solution approach should be. So let me expand and let's get our sample input also from this. So sample input was this. Let's put that here and let's try to run this code and see. Do we get the output that we predicted, that we worked out with pen and paper? There are some mistakes. A should not have been used. I think I'm using wrong variable names. So A, it should be V of start because we have a vector. Let's see what other compilation errors I got. A was not declared. Too few arguments. When I'm calling solve function, I should be passing 2 arguments, n and k. I need to scan k also. Let me declare 2 variables n and k and read n and k because our input format is giving n and k as the first line of test case. Let's submit. So now we see, okay, one more compilation error. What is that? Too few arguments. Oh, sorry, I did not add that k when calling the function. Yes. So k also added here. Let's submit now. So that was the only compilation error, I believe. Yeah, compilation gone through. Now we are running. What is the mistake? Why we are getting 2 test cases output on the same line? Ideally, we should have got 2 lines of output like this. And I say answer is also coming wrong. Okay, answer wrong we will see. But only thing is here right now I'm missing out my new line here. So let's see what mistakes are there in the code and try to figure them out and fix them now. So output for first array should have been, it should not be 3, 4, 5, it should be 6, 9, 12. Are we getting 3, 4, 5? For second array also our output is wrong. Can somebody tell what is the mistake in this code? Looking, code is in front of you. Can you figure out what mistakes I have made? Yeah, this will be more visible. So Bhavish is saying we are not adding v dot end. Bhavish, we are adding that here. In this line, there is a mistake. Can you catch that? We are adding v dot end every time. But I have done a mistake, which we need to catch and say, hey, that is the mistake you are doing. When you type the code, you did not take care of that. Yeah, it should be plus is equal to. It should not be equal to. So this is a mistake that I made. So we should be adding, and in place of adding, I'm assigning. So since I'm assigning, we'll certainly get wrong answer. So let's go back and fix this code where we were not adding, we were just assigning. So this is the expansion of window. Let's submit. So now we see we are getting 6, 9, 12. And if you see, this was the output that we predicted. This is the output we are getting. Right, so this is our first code for sliding window. I'm just putting this link in our chat window. So you will be able to click the link. You will be able to see this code. And this code is the base code. We are not going to solve this coding problem, but based on this thought process, this thinking, we will be doing other programming problems that are created as an assignments, which you will be given link to. You can start solving them. So let me come back to these notes. So this is our solution. And now can somebody tell me what is the time complexity of this code that we have worked out? What is the time complexity of this function? Yeah, guys, what do you think is time complexity of this? Yeah, so time complexity of this is n. And as you clearly see that this loop is running n times. First line will run in constant time because we are just adding. Condition we are checking constant time. We are printing, it's a constant time. We are calculating something, it's a constant time. Plus plus, it is a constant time operation. So we are not having a loop inside loop. We are not doing anything. Okay, Manish is saying n into t. Yeah, Manish, for this function I was asking, for this function time complexity is overall n. But if you look at, combine it with main, in main function, for every test case, we are doing n. For every test case, we are doing n. Overall program's time complexity, you will say n into t. But for this function, time complexity, you will say is n. Make sense? Okay. Whatever we have learned right now, this is called fixed size window. Because here the window size that we had, it was fixed, and window size was fixed to size k. We had a window of size k. This is first pattern of sliding window technique. Many problems are based on when window size is given to you. Second category of problems, just be aware of that also. There will be a variable size window. That is the second pattern we will take a look at. So first pattern we have already talked about. Second pattern also we will see. That will complete our topic. That will give you enough context about this technique, and then you will be able to attempt problems. So let me take the second motivation problem as an example. So this was first problem. Let me take as problem 2. So this problem says, given a string of size n, find smallest window length that has all distinct characters. Now, what do we mean by this line? What is the problem statement saying? So let me take an input example here for you. So let's say the input is AA, PP, LE, ST, OO, II, PP. Can you tell me what is the smallest window length in this string which has smallest window length, or call it smallest substring, smallest window length or smallest substring length, in place of window, we can have substring also that has all distinct characters. In this string, can you tell me what is the smallest string that has all distinct characters? So Manish is saying it is 5. So Manish, what is that string? 5 length is LESTO, PLEST. Manish, why not this? Whatever I have highlighted, why not Plesto? So what is the length? Answer should be, we are finding the length. Answer should be 6. So this is just to kind of clarify the problem statement. So everyone clear? Like if this is our given string, our length is 6. If I give you another string, if I say A, B, B, C, C, D, D, E, E, what is the length? What is the answer now? Yeah, Shakti, what is the answer now? Why? See, Vaishnavi, you have to think of smallest substring window which has unique, totally distinct characters. You are ignoring this fact. AB is also a substring. Isn't AB a substring of this string or sub-array of this array? Ajay, Vaishnavi, people who gave Ajay, Madhavi, you gave 0 answer. Just see that. Do you agree with this that AB is a substring which has distinct characters? Which is 2. Do we have any substring which is greater than 2 length here, which has unique characters, but it should be greater than 2? Can you find any other substring in this string? Or 2 is the highest? We can say 2 is the highest, right? We cannot find anything bigger than 2. Now, if I ask you in third string, I'm giving you, tell me what is the, question should be largest. But in this, what is the largest? What is it that you can find more than this? Somebody asked, like, we have to find largest. But in largest, can you find larger than 2? We found 2. Before, larger than 2 was not possible. In third case also, larger than 1 is not possible, because if you make it, if you're making your window bigger, you're going to have duplicate characters. We don't want duplicate. Yeah. Is it making sense to everyone? Yeah. So now we understood the input, we understood the output. Now, how do we solve this problem? And this problem, if you see, window size is not fixed. Window size is not given to us. So we need to see, like, how do we solve this kind of problem? Since it is a substring problem, subarray problem, we will start with our technique and say, hey, let's see, imagine we are not able to see the input right now. So we will gradually start calculating things. Again, we will take a start and end. I'm revealing the characters. I'm changing this time the input. I'm revealing the character. Okay. Jitendranath is saying, can you discuss first test case again? Sure, Jitendra. So in first test case, what is the longest substring that has, okay, Sushank, I'll come to your question also. Yeah, so Jitendra is asking question, can you think of the, look at the first problem. So in first test case, longest substring we said, let's start from A. Can AA be the longest substring? Answer to that is no, right? So you have to leave one A, then P comes. So you cannot consider this substring because this substring has P 2 times. So we come to this P. This is what people are saying. The highlighted portion that you see, that Jitendra, people are saying that this is the longest substring. There is no longer substring than this, which will have all characters as distinct. Do you agree with that, Jitendra? Do you have any other substring of this string, an example, which is longer than 6 and it must also have all characters, unique characters? Yeah, Jitendra, can you? Yeah, so that is how we said, hey, 6 is the answer, because the moment you start expanding it, a duplicate character comes, and that is not something that we want. So this is how we kind of come up with the output. So first test case is clear to you? Perfect. Okay, I thought we were discussing smallest. No, it is the longest. Sorry, I made a mistake. I'm sorry for that. Yeah. Okay, I think that is what people were typing in the chat window. So we have to find the longest window that has all distinct. Sorry, that was my mistake. So Now it is clear. Because smallest will always be 1. If somebody asks the smallest, we will say, hey, all. Yeah, I got it. That was a mistake. Okay, so now problem statement should be clear. There was one more question that Sushank sent. Sushank asked, what if string has spaces in it? So if string has space, we will consider space also as a separate character. Now, ideally, if you see, in this case, this substring has all unique characters. Space is also a valid character, right? So Sushank, that answered your question. That if space is there, that is also treated as a separate character, and two spaces together will not be considered as distinct. Sushank, clear? Yeah, in this case, if space is there, now we will say there is a substring of length 7, including space. Yep. But when I'm discussing this problem, I'm assuming, let me say, I'll put that constraints also, that string will not have spaces. So this is how we are starting. Now, this should be clear. First line will tell the number of test cases, then inputs are there, and then you have output. So problem statement is making sense to everyone, what we are talking about. Perfect. So if problem statement is clear, let's try to see like how do we solve these problems. So imagine I'm not telling you what string I have in my mind, but I will reveal the strings or the characters one by one to you and see that can we work out an approach. So the first character is A. Can you tell me till now what is the longest substring length with all distinct characters? Still now, all distinct. Till now you will say 1 because you have seen the first character. Now, based on our sliding window, I will also ask you to see, let this be the end. This will be the start of our window of our substring. Just a moment, guys.
This conference will now be recorded.
Guys, am I audible now? Can you confirm if I am audible now? Yeah, in between, yeah, some glitch happened. So perfect. Yeah, so what I was saying, I just gave the indices to every index here. So I have just put 0, 1, 2, 3, 4, 5. So what I was saying is, imagine if I reveal the next character to you, it is B. If next character is B, we are expanding our end. So we are trying to make our window bigger because we have to find the longest substring that meets our criteria. So if I reveal B is the next character, you move E here, you check this character, it is B. It is different than the previous character. Now, can you tell me what is the longest substring with all distinct characters so far? It is 2. So let's update that. Right? Now let me go to the next character and ask what is the next character. So see, we are being greedy now. We are expanding our window so that we can find the highest length substring. Now if I tell you next character is also B, now what will you do? Next character is also B. So still you will say the longest window answer is still 2, which is the previous thing. So this B including is not something that's a good idea, right? because now our substring has become a substring which has duplicates in it, which is not acceptable. So we have to continue our search because next three characters I'm going to reveal to you is CDE. Now, overall answer, can you tell me what is the overall window length in this test case that we should get as an answer with all distinct characters? It is 4. So Nikhil, check your answer. It is not 3, it is 4. B, C, D, E, right? So we need to devise a strategy using sliding window. Now, when we come to this B, this is our end. So we say, hey, since we have got a duplicate in this window, let's try to shrink our window. So shrinking window means what should we move? Our window was S to E. For shrinking, we should move S. Do you agree? Yeah, we should increment S. And you keep incrementing S till the time you don't come to a point where duplicates are removed. So duplicates will get removed only when you get rid of this A, you get rid of this B. Now you are gone with duplicates. So far you got the answer. You removed those things and you say, now I have reached this B. Now at this point, there are no duplicates in our window. Our window is where S is 2, E is 2. That is where our window is right now. Now again, we come to a point, since we have distinct characters, let's start incrementing our window size. Next character is C. You increment, this is the window you got. You say there are no duplicates so far. Next character is D. You increment E here. Okay, no duplicates so far. If you are given this S and this E, how do you calculate the window size? Based on S and E, can you tell me a formula? What will be window size if S and E are given? S is at 2, E is at 4. What is the size of window? Right now, what is the size of our window? What is the substring length? If S is at 2, E is at 4, it is 3, right? So the formula that we are saying is, Ajay, it should not be S minus E. S is lesser, E is greater. It should be E minus S plus 1, right? That will be the window size. Now, whatever window size we got, this is greater than the window size we already had. Let's update that with 3. Hey, we have got a window size 3 so far. Now we take a look at the next character. Even that character is distinct. It is in this window that is also distinct. Then you say, okay, this is the window that we got, which is size 4. Let's update our best answer as 4. So we say, in the end, we have completed the string. So we say we have exhausted it, and we have got 4 as the longest window of our interest with all distinct characters, right? So this is the technique. But one thing we need to think about is, how will we know current window has duplicates or not? Which data structure helps us find duplicates or not duplicates easily? Because when you are at D, you will not be going back and searching. Yeah, ideally we know set is a data structure for that. And if we use set, now we have to remove a character from window also, right? When you are moving S, your character should get removed. So rather than using set here, we will be using a map, and map will have the character and its frequency so far, which is int. So we will be using a map of char comma int. Yeah, so Shank, we will be removing A, but somehow in memory we need to know whichever substring we are considering so far, which characters are there and how much is their frequency, because that is how we will get to know. Imagine if here another B comes, when this B comes, you should also know that now it has become a duplicate. So now when you are removing this B, then only you will include this B, right? We will see the implementation of this, then things will become much better clear why we are talking about using map and why not set. So this problem statement is clear, input function is clear. Let me quickly go back to write just that function so that we don't worry about input reading for now. And I'll say, can you tell me what should be the function, appropriate function name? The problem we are solving is longest substring with linked chars. What should be the input parameter? What input do you need to solve this problem? What is our input for this problem? We are writing a function. We will have some input and we need to give the answer of longest size. For one test case, I'm writing this function. See, this is the problem statement. What should be the input to our function? Anyone? It should be the string. So we are getting string S for which we have to give the answer. Right? Let me call it str. Okay. Now, as I said, we will take a map of char comma int. This will remember the frequency. Then we will take a start, which is 0, and initially, which is 0. And similar to what we did earlier, we will write a loop for end is equal to 0 and less than n and plus plus. Now tell me, how do I get size of the string? How much is the total number of characters in the string? How do I get that? Str dot, what is the function for getting, this is C++ string, not character array, dot length. So length is a function, we call that, we get the length of the string. So here again, you see, we are going with expanding the n and always. So our focus will be keep extending n and then continue. Now, what should we do when we see the first character? When we see any character, what should we do? Look at our strategy we discussed here. When we saw the first character, A, you immediately told me that substring is of length 1 so far, right? So what we will do, we will also remember max substring length. So far, we will keep it 0, right? Initially, when you come, we will say our frequency map of current character. Current character is C, str of end. This is the current character we have freshly seen. Can I say add frequency in the map? So whenever we see the first A in our map, we say, hey, A is seen 1 time. So there are no duplicates so far. All good? If it is all good, we will check if frequency of C is 1. It is not greater than 1. We will do something. And if it becomes greater than 1, we will do something else. If the frequency of C is still 1, you got another C and this one is telling you, so this is a unique char. Can I say if this is 1, if A got added and in map earlier A was not there, there are no duplicates so far in our substring, then I am able to calculate my substring length. Can I say max substring length is equal to, max length is equal to, there is a built-in function max, this comma end minus start plus 1. Do we all agree with this? This is making sense? So we have just included a character. Imagine we looked at A, that was end is 0, that we have put that in the map. And in map, we have seen this is the first time we are seeing this. So our substring length is still 1, not changing. So that is what is the first answer we got. Now, after adding this, map does not have anything duplicate. So we will continue forward. Yeah, guys. So this if condition is understood for everyone. Now imagine if this character was a duplicate. Let's come to the next point. Imagine if next is A. What should we? Now if our next character is also A, now what will happen in this loop? We will come. Right now, this loop is always expanding the window. Right? Yeah, if next character is also A, what we will do? We will increment S. Yes, Ajay, that is what we will do. Until what time should we increment S? Till what time should we increment S? Can I say while frequency of C is not equal to 1, or if while frequency is greater than 1 of current character, what we will continue doing? We will say start plus plus, and we will also do one thing, frequency of that we will keep on doing minus minus, right? So we are continuously removing, not C, in fact we should say A of start. We are removing all the characters from our map which were added so that we can reduce the window. Is this clear to everyone? What is this loop trying to achieve? This is actually shrinking our window. And now I can put this here also, because this loop will not run if the frequency is already 1. And after shrinking, I can get rid of some if and else. Just see this code now. This is much cleaner, much shorter. What we are doing, every time we see an end character, we add its frequency to map blindly, even if it is duplicate. Then we try to neutralize our map. We try to remove the starting elements. And in the end, because after this while loop, this is guaranteed that the duplicate character we added, after that we have shrunk the window. And if we have shrunk the window, this is the answer we will get. And in the end, we will return max sublength. Yeah, okay. Until we reach C. Yeah. So see, this is something that we have written. Let's just try to see what this function will do. Rather than doing a pen paper based thing, I'll call this function quickly to understand what we are doing. So this is variable size window.cpp. I'll call this function with some string that we had already written or discussed in our input. So in our input, we talked about some strings. Let me take that from notes. So this is the string I'm picking up. Or let me initially go with a smaller string. Let's take something smaller so that we can digest and understand the concept. So I'm calling it with A, B, C, A, B, D, E, F. Yeah. So this string will make much more sense. So we are calling this, and what I will do one more thing. After every frequency increment, I will print a message, printf. I will say our max length we will calculate, printf. Start is something, start is equal to %d, end is equal to %d, and max substring length is equal to %d. This will just help us visualize what is happening. Start, end, max, sub length, right? So three things we are just printing in our loop just to see what all it will do. So let's go back and compile our code. G++ thing 0 not is variable size window. Okay, A of start, again I'm using A, so habitual of taking A as an array, so str. Yeah, so this got compiled. Let's run a.exe, and you notice here initially start was 0, end was 0. We took the first character. Let me bring the input side by side. So our input is this, yeah, and notepad, and I'll put this input here. So this is the input we are tracing. See, when start was 0, end was 0, our max substring length was 1. In map, only A was added. Then we expanded end became this. Now the substring length became 2. So far, no duplicates, no problem. When we come to C, end became 2, substring length became 3. Now the moment we came to A, when this A comes in, we will put that in the map. Now you see things start changing. Our A will become twice in the map, B is once in the map, C is once in the map. This is what we see the moment we have seen this character where end became, our end has become 0, 1, 2, 3. This is where end is 3. Our start was still at 0, and now we got a duplicate. And this time, the moment we get a duplicate, what we should do? We should start shrinking our window. So shrinking window means Let's start removing the starting character A. Remove starting character. Removal means we are incrementing S, and in map we are decrementing the count of that character which we are removing, which is A of start. So that is what we said in string of start. From map, frequency map, we are subtracting. So this will become 1. And we continue doing that till it reduces to 1. Now it has become 1. Start has come to 1 and has come to 3. Now tell me, what is the window size that we are considering? From overall string, we removed A. Now we have focused on BCA. So our string has become BCA. S has become 1, E has become 3. And this is what it is telling. Max is so far still 3. Start is at 1, end is at 3. So this loop helped us get rid of the additional characters, right? Then if we continue post that, now we removed A. Now this became our window. Let's start expanding the window. So end becomes 4 here. So this was start was 1, end became 4. But again we got a duplicate. So for duplicate, we will start removing characters from the beginning. So B will get removed and cab will become our focus. At cab, we will again see the string length is 3, max length is still 3. Next loop iteration, we'll get D in. Now no duplicates, so total string length is 4. Next iteration, we get E in, length is 5. Next iteration, we get F in, length is 6. So starting at 2, ending at 7, max of string length is 6. This is what we got as an answer. Is the concept clear? Do you get it? I'll just comment out this line. So guys, this is where the window size is not given. We call this technique as you keep expanding your window, S to E, keep moving this forward, and once you feel I have reached a point where I need to move S, that is where you shrink your window. There are coding problems based on this pattern also that come. So most of the problems where you talk about find the longest substring or longest subarray, longest or shortest subarray, then that is also where you can apply variable size window. That technique gets applicable here. So this is what we had to discuss concepts wise on the sliding window technique. Do you have any questions, any doubts that you want to clarify on this? These notes that I have written, I'll be sharing that in your group, so you will have access to these notes. And whatever code we have written just now, I'm pasting that also in IDE1 so that you have access to that as well. And we will do now what we will do a quick summary of whatever we have discussed, and I'll share you a contest link where you can practice the problems where you can apply sliding window, both fixed size window, variable size window. So that is something that you can try for next one day. And after that, we can keep a similar session where we can discuss the solutions to those contest problems so that you get to learn from them also, right? So yeah, this is the code that we wrote, and let me put that also in our class notes, which is here. So variable size solution and this. So to do a quick summary of whatever we have talked about, we learned about subarrays, right? We talked about certain formulas of subarrays. So we talked about what is a subarray. Then we talked about how many k size subarrays are there and what is start index of last such subarray. Then we talked about fixed size window problem, right? And third, we talked about concept of variable size window. And overall, the sliding window technique is helpful in solving subarray problems in linear time where brute force solutions take either n square or n cube time. So all such problems get reduced to linear time, and this technique is very effective. Once you know this technique, once you identify that the problem you are attempting, that you are solving, will get solved with this, you will be able to do those problems with better time complexity. Yeah, guys. So this is the summary of what we discussed. So let me know if you find these online sessions to be convenient and you feel like, yeah, I'm able to follow things in online. If your feedback is positive that these sessions are helping you, we can plan more of these and we can make good use of this summer break or this corona break. Can you type in the chat window? If you feel comfortable, just put yes. If no, just put no if you're not comfortable. Yeah, Mithil, I'll come to your point. Just a moment. Yeah, I guess most of the people here are saying yes. If anybody is not comfortable, feel free to raise your voice. It's not a push for anyone. Okay. Yeah, so if the answer is yes, okay, somebody is asking, Shashank is asking, when will you share the video? Shashank, video will not be shared because that makes people lazy of not attending these sessions. I don't want that to happen. So these sessions are going to benefit only those people who are devoting their time, are having this patience and energy to attend the classes live. So videos are not going to be available. Right. Second thing, Mithil shared a question yesterday. So what I will say is there is a next session planned for you guys, greedy algorithms, that will be taken by Jay Krishna. Jay Krishna, you are there in the call? Can you unmute yourself? Okay, Jay Krishna is there, but I cannot hear him. Yeah. So Jay Krishna is, a good competitive programmer. Yeah. So Jay Krishna, you will be taking next session on greedy algorithms on Saturday. Is that correct?
Yes, sir.
Yeah, which is tomorrow. So guys, tomorrow 3 p.m. we will have next session on greedy algorithm where Jay Krishna will give you context of greedy and he'll prepare you one more topic, and then we will have some practice problems for you on greedy algorithms also. So these questions that we talked about, this concept that we have talked about, there is a practice set, practice problems that are created on this by Prashant. Prashant is also there in the call. So Prashant, I'll add you to their WhatsApp group. So people who have doubts in those problems that we are giving you as an exercise, feel free to drop in your queries in the group and we will answer it there. And if required, we can do a separate session to take up your queries and discuss their solution. So these are the two folks who are going to help us regarding these two topics. So next session we'll have tomorrow 3 p.m. And till then, I have put up one link which I'll put in the group, which is created by Prashant. So start solving those problems on sliding window. Right. So thank you so much, guys, for spending time. So let's continue the same energy, passion for coding in these days.